Hey guys, this is Souradip Sarkar, your mathematics mentor. You are watching right now Canvas for JEE YouTube channel. So today in this video, this is the lecture 2 of method of differentiation, or rather you can say that method of derivatives. So in this video, we are going to deal with the quotient rule and the chain rule. Quotient rule and the chain rule. Okay, so let's start today's lesson without delaying. Let's start. Okay, first of all we have to deal with the quotient rule. Okay, now the question arises that what is quotient rule. I am writing on here, that is ddx by gx. This can be written as f dashed x gx minus g dashed x fx divided by whole divided by g square x. Okay, this is our quotient rule, or rather in another type you can write it as ddx of u by v. It can also be written as u dashed v minus u v dashed divided by v square. Okay, this is the quotient rule for the methods of derivatives. Okay, so let's go for the next part, that is chain rule. Our chain rule, let's start from the beginning. That what is chain rule? The main formula of the chain rule, that is ddx of f of gx. It can be written as f dashed gx into g dashed x. First of all, in f dashed gx, we have to take gx as a function, gx as a function of x. Then we have to first take the derivatives of f of gx, and then after that we have to take the derivative of gx. Okay, so by taking an example, it will be easier for you. That let's take an example. That is ddx of sine cube 2x plus 5. Now see here, sine cube something, it is a function, and 2x plus 5, it is also a function which is included in sine cube. Okay, so first of all we have to differentiate the sine cube of this part. Okay, it will be 3 sine square 2x plus 1 2x plus 5, and then we have to differentiate over the sine cube something, and that is cos of 2x plus 5, and after that we have to differentiate 2x plus 5. That is if we differentiate 2x plus 5, that will be into 2. This is the answer. 3 into 2 6, that is 6 sine square 2x plus 5 into cos of 2x plus 5. This is the answer of this question. Okay, first in here you can memorize this as p, b and a. What is p? P here we have to first deal with the power of the function, then we have to deal with the base of the function, then we have to deal with the angle of the function. Okay, I think you should remember this, and let's go for the some different types of examples. That is example number 1. You can see here, that is ddx of 10 power 5 7x plus 2. You can write it as here. First of all, you have to differentiate 10 power 5 something function of x. Okay, 10 power 5 something function of x. You have to first differentiate over that. It will be in the previous you have seen that first of all we have to deal with the power section. Okay, so here the power of 10 is 10 power 5, so we can write it as 5 10 power 4 into 7x plus 2 into then we have to differentiate tan of 7x plus 2, so it can be written as tan of 10x. Differentiation of 10x, it will be sec square x, so we can write it as sec square 7x plus 2. Okay, after that we have to deal with the 7x plus 2 function, that is it will be 7x, the derivative of 7x plus 2, it will be as it is 7. Okay, this is the answer, and let's go for the next example, that is ddx of cos square x cube. First we have to deal with the power, that is 2, so we have to write it as 2 cos x cube. Then we have to take the derivative of cos x cube, that is minus sine of x cube. Okay, this will be minus sine of x cube, and after that we have to take the derivative of x cube, this will be 3x square. This is the answer. Next example, that is ddx of ln power 5 2x plus 3. First of all we have to deal with the power, that is 5, so it 5 ln power 4 into 2x plus 3. Then we have to deal with the function of ln 2x plus 3. It can be also written as something ln x. The derivative of ln x will be 1 by x, so we can write here as 1 by 2x plus 3, and after that we have to deal with the 2x plus 3, that is the derivative of 2x plus 3, that is as it is 2. So this is the answer of the question. Okay, let's go for the next question, that is I am writing down the question over here. If f1 equals to 1 and f dashed 1 equals to 3, then the derivatives of f of fx plus fx whole square at x equals to 1 is. Okay, this is the question. This question belongs to I am writing here that JEE Mains 2019. Okay, the options are option A 33, option B 12, option C 15, and option D is 9. Okay, and let pause the video and solve the example, solve the question. After that, after solving that, and see my solution of the question. Okay, okay, let's start the solution of the question. First of all we have to here it is said that we have to take the derivatives of this okay, yellow. So first of all we have to take the derivative of this function here, this function we have to take the derivatives. Okay, so first of all here the derivative of the function will be f dashed f of 1 at the point of 1, it is determined in the question, into f dashed f of 1 into f dashed 1 plus 2 into f1 into f dashed 1. have a time. I think you will understand the question, or if it is difficult for you, then write it down elaborately and then differentiate it. You can see this expression is coming over here. Okay. So first of all, here that f of 1 we have, f of 1 we have get as it is 1, so we can write it f dashed. F of this part we can write it as 1. Okay, f dashed, f of 1 here in this part we can write, okay, I am changing the color, it will be this part we can write f of 1, and for this part we can write it as f of f dashed 1, and here also f dashed 1 is there, plus 2 into f1. In this part we can write f of 1, that is 1 into f dashed 1. So now f of 1, f of 1 here also it can also be written as f dashed this, okay, this part can also be written as 1 f dashed 1. After that, wait a minute, f dashed 1 into f dashed 1 into f dashed 1 plus 2 into f dashed 1. This is, so here in the question it is given that f dashed 1 equals to 3, so 3 into 3 into 3, 3 into 3 into 3 plus 2 into 3, that is equals to 3 into 3 into 3, 3 power cube, that is 27, plus 3 into 2, that is 6, 27 plus 6, that is 33. This is the answer of the question. Option A is correct. Okay, option A is correct. Okay, I think you should understand this question, and let's go for the next question. That is this question. This is right in front of you. This question belongs to changing the color, JEE Mains 2020. Okay, this is JEE Mains 2020 question. And let's read the question. That is, let y equals to yx be a function of x satisfying y root 1 minus x square equals to k minus x root under 1 minus y square, where k is a constant and y function of a half equals to 1 by 4 minus 1 by 4, then dy dx at the point of x equals to half will be equals to. Okay, pause the video and go to solution of the question, and after solving it come here, I am giving the solution of the question. Okay, let's start the solution. First of all, we have to signify about this function which is just given in the question. So let's go y root under 1 minus x square, and this is minus x root under 1 plus y square. We are taking it in front over here, so it will be looks like root under 1 minus y square equals to k. So then we are taking derivatives in the both side. Okay, before that we have to, here we are assuming two functions over here, that is x and other is I am changing the color just right now. Okay, we are here assuming two functions, that is x and another is y. So x is the function of sine over capital A and y is the function of sine over capital B. These are the two functions over here, and see, this x is given here also, this x is also given here. So if we put the value of x, then it is comes as y. So here in this case you can see that if the value of x is half, then the value of y will be 1 by 4. It is just crystal clear over here. Okay, let's go for the next part, that is y. We are putting the value of x equals to sine A and assuming, I am writing here, Okay, x equals to sine a, y equals to sine b. We are putting the value of the x and y over the function which is given in the question, that is y equals to sine b and y equals to sine b, and then root under 1 minus x square, that is root under 1 minus sine square a, that is cos square a, that is root under cos square a, we can write as cos a. After that we have to take the value of x, and that is sine a, and root under 1 minus y square, that is cos b. Okay, we can write it over here equals to k sine, here you can see sine a cos b plus cos a sine b. We can write here sine of a plus b equals to k. Okay, then we can write a plus b equals to sine inverse k. Yeah, we can write. Then what is a? We can write, instead of a we can write sine inverse x, and instead of b we can write sine inverse y. See in the first of all we have assume x equals to sine a and y equals to sine b. Okay, so in the place of a we can write sine inverse x, and in the place of b we can write sine inverse y, and sine inverse k is as it is there. We can write as here the k is the constant, so sine inverse k will comes as a constant value, so we can represent is as k. See, okay, assuming. Okay, I think from this part it is clear for you. Okay, let's go. So we have got that sine inverse x plus sine inverse y equals to c. C is a constant. Now in this step we have to take the derivatives of in the both side, ddx of sine inverse x plus sine inverse y equals to ddx of c. We are taking derivatives in the both side. So ddx of sine inverse x plus sine inverse y, we can write it as 1 by root under 1 minus x square plus 1 by root under 1 minus y square into dy dx. Yeah, we can write it here, and ddx of any constant, that is always will be 0. Okay, so now what will be the value of dy dx? The value of dy dx will be equals to negative minus of root under 1 minus y square divided by root under 1 minus x square. This is the value of dy dx. So now the question says that find the dy dx at the point of x equals to half. Okay, find dy dx at the point of x equals to half. So we have to find the dy dx at the point of x equals to half. I am changing the color in red. So dy dx at the point of x equals to half, we can write, if you can see that if the value of x equals to half in this function, if the value of x is half, then the value of y will be minus 1 by 4. It is given over here as it is. So if the value of x equals to half, then the value of y will be minus of 1 by 4. So we can write it over here that if we have put it the value of x as half, and we have to put the value of y equals to minus 1 by 4. Okay, so let's see, minus in y square we have to write minus 1 by 16, and root under 1 minus 1 by 4. This is the answer, that is root under minus 15 divided by 4, that into 2 by root 3. So we can write it here, that is minus root 5 by 2. This is the answer of this question, and I guess option B is correct of this question. Okay, option B is correct over here. have a look over this question. First of all, we have assumed as x equals to sine a and y equals to sine b for our convenient process. Then it is comes as a plus b equals to sine inverse k. We have take a as sine inverse x and b as sine inverse y, and sine inverse k we have assumed as c, which is constant over there. After that, sine inverse x plus sine inverse y, we have taken the derivatives in the both sides. Okay, we have take the derivative in the both side, then we have find out the value of dy dx, and after that we have to find out the value of dy dx at the point of x equals to half. Then we have put it the value of x and y over there, x equals to half and y equals to minus 1 by 4. After that, the values comes as minus root 5 divided by 2. Okay, with this we have ended our this session. Okay, so I think you have understood all the questions over here. We have solved JEE Mains question 2019. After that, 2020 subsequent years question we have to solve here. We have solved here. Okay, so thanks for watching this video. I think you have understood all the concept and quotient rule and chain rule over here, and share these videos with your friends so that all of get the free content over these channels. Okay, so with this I am ending this video, and till then, keep learning and keep exploring, and subscribe our channel and hit the bell icon for further notification. Okay, thank you, bye bye.